Hi everybody. In this video we are going to be talking about unit 13.2.2, which is writing the equation of a line using slope-intercept form. So as a reminder, our slope-intercept form is this y equals mx plus b. Again, reminding you that m is our slope of our line, which is our rate of change, and b, we would typically write it as an ordered pair when we get ready to graph it, but that's going to be our y-intercept of our graph. So again, that we can use this form to graph our equations. And so, if we've got our coordinate plane there, and if we're graphing something like this, this point right here would be considered our y-intercept because it is where it intersects our vertical or our y-axis. And then this point over here is going to be our x-intercept, because that is where our line is going to cross our x-axis or horizontal axis. And then our slope, again, would be our rate of change between two ordered pairs. So our rate of change is the rise over the run. All right. Another just kind of note, we are doing this section out of Ed Ready's Order 2. Sometimes they change up the order, sometimes they don't, in terms of how I teach these graphing, the topics in the graphing unit. So just be careful when you're doing your homework. Make sure that you are looking specifically for the writing the equation of a line topic, and you're doing the practice problems for the correct topic. So just be aware of that. All right, so here are 4 scenarios we might be presented with when we're asked to, write the equation of a line in slope-intercept form. So first scenario is that literally they will just give you the information. So they will give you the slope and then the y-intercept. So if given the slope and the y-intercept, simply substitute the information into the formula for m and b. So for example, if it says write the equation of a line that has slope of 1/2, so we know that's going to go in for m because it says slope, and goes through the point 0, -5, then we are to write the equation of a line in the format of y equals mx plus b. Well, question for you, how do I know that this point is my y-intercept? I mean, because I already told you before we started this problem that they give us the information. So that means that this is the 1/2 is our m and that this point is our y-intercept. But you should ask yourself, how do you know that that is our y-intercept and it's not just some other point? Well, how we know that is that it started with a 0. So anything that's going to be along our y-axis here, this vertical axis, our x's are 100% always going to be 0. It's going to be, so if I put some point down here and I said, what's the ordered pair for that? It's going to be 0 and then some negative y. This point at the origin, 0, 0. This point up here would be 0 and then some positive y value. So that's how I knew that this is a y-intercept. So y-intercept always starts with 0. Or a better way to even say that is that the x value is always 0. All right, so that's how we know. So anyway, now we're going to plug in this 1/2 in for m. We're going to plug in this -5 in for b, and that's going to be our answer. It's going to be y equals 1/2 x minus 5. And it's minus because there's a negative over here. I've had students ask, Liz, can I go ahead and write y equals 1/2 x plus a -5 like that? Sure, that's fine. But you don't have to, you can just write -5. All right, let's look at the next one. So again, scenario 1 is that they literally just give you the information. Well, here's scenario 2. If they give you the slope and a point on the line other than the y-intercept. So this time it's similar. They're giving us the slope, And then they're giving us a point that is not the y-intercept, but it's a point on the line. So then we are going to substitute the information into the formula, this time for m, x, and y. So look at how that's different. We're not going to sub anything in for b yet because that's our next step. Then we have to solve for b. And then once we figure out what b is or what our y-intercept is, we're going to rewrite the formula with m and b substituted back into the formula. So here's our example. We can write the equation of a line in our slope-intercept form. So it needs to be in the form y equals mx plus b. And it has a slope of 3. So that's going to be our m. And it contains the point 2, 6. So the next question you should ask yourselves is this the y-intercept? It's not the y-intercept because we have something other than 0 for our x. It's 2. It's 2, 8. So what that means is I do in fact have another point on my line that's not the y-intercept, which means I'm going to sub x or 2 in for x and 8 in for y. And it again, because that's our ordered pair, right? So an ordered pair goes in the form of x, y. And so what we do is that we are looking for b. So it gives us all of these pieces of information. It gives us a y, an m, and an x. And we're gonna do some mathematical work here in order to solve for b. So let's do that. We're gonna plug 8 in for y. And we are going to plug 3 in for m and 2 in for x, and we're gonna solve for b. And again, we're doing these steps up here. So it tells us to do that. It says substitute these in for m, x, and y, and then solve for b. All right. So now I'm going to come up here and we've got 8 equals 6 plus b. Subtract the 6 from both sides, and 2 equals b. All right, so now that we have solved for b, we are to rewrite the formula with the numbers m and b substituted back in. So we are gonna, our m again is here, our b is here, and now we're gonna substitute it back into our formula right here. So y equals 3x plus 2. Y equals 3x plus 2. All right, let's try our third scenario. Third scenario, if we are given 2 points on the line, and again, it's not just any 2 random points. It's if we're given 2 points that land on the graph of our line, we need to first calculate the slope or find the slope, right? Like we're gonna do y2 minus y1 over x2 minus x1. We're changing y over changing x. So that calculate the slope, again, go back to the day where we were talking about finding slope. So changing y over changing x. Then we're gonna follow the same steps as number 2 that we just did up here. Because once we've calculated the slope, we have exactly this situation. We have the slope and we have actually 2 points on the graph of our line, but we just pick one. It doesn't matter which one we pick. You can choose either one to substitute it back in to solve for b. All right, so first we are going to, first step in here is to find the slope. Because it says, write the equation of a line that passes through the points 1, -2, and -1, -6. So I'm gonna find my slope. Change in y over change in x. So I'm gonna go -2 to -6. So -2 minus a -6 all over 1 minus a -1. And so then we're going to get -2 plus 6 is going to give me a +4. 1 plus 1 is going to give me 2. I get 4 over 2, which is 2. So here's my slope. And now I need to pick which ordered pair I want to use, either this one or this one. It does not matter. You can use either one. And we're going to substitute one of those ordered pairs in for x and y. We're going to substitute this 2 in for our slope, and we're going to find our y-intercept. So our second kind of big step here is to find the y-intercept. And so here we go. I'm going to substitute this one in. Again, it doesn't matter. You could have picked the other one. I'm going to do -2 in for my y. So I'm substituting it into y equals mx plus b. So my -2 is my y. My m is this 2 over here, the 2 that I just found. And then my x is +1 plus b. So then I get -2 equals 2 plus b. I'm going to subtract this 2 over, and I get -4 equals b. So now your third step is to plug it all back in. So we've got our slope here, our y-intercept here. Now you're substituting it back into y equals mx plus b. So y equals, what's our slope? It's 2, and then x, and then our b is -4. So it's going to be -4. And that's your answer, is the 2x minus 4. Now, something you can always do, like if you wanted to check, if you're like, oh, did I do that right? Let's check it. Pick one of your ordered pairs. It doesn't matter. You can pick either one and check it and say, okay, what if I plug in -6 for y and I say, does that in fact equal 2 times -1 minus 4? So I'm plugging this and this in for my x and y just to check it. So then I would go -6 equals -2 minus 4, and that gives me -6 equals -6. Check. So that means I did it right. If instead I got something over here, maybe I got like -4 equals -6. Well, that's obviously wrong. Like -4 is never going to equal -6. If I got something like that, that would mean I messed up somewhere in my process. You know, some of you are maybe in step 1 or step 2. I would just need to go back and check my work and find out if I did something wrong. All right. So here's scenario number 4. What if we are given a graph? So we could be given a graph of a line, and then we need to identify 2 lattice points on the line using the y-intercept if possible. From that, then we're going to calculate the slope by doing our rise over our run. And then we are going to substitute the information into the equation. All right, so let's figure out our slope first. And I'm going to tell you right now, when I'm looking at these, the black line, the solid line looks easier versus the dashed line. And here's why. When I'm looking at them, I'm looking at the fact that the solid line, it crosses our y-intercept at a really great lattice point. We'll look at the dashed line. It's somewhere between -2 and -3. It looks pretty close to -2.5, but is it for sure at -2.5? I have no idea. So what we're going to do is we're going to calculate it and figure it out. So this is kind of a question mark, like it's maybe -2 1/3, -2 2/3, -2.5. I don't know. So we're going to have to figure it out. So that means I'm going to do the solid line first because it's going to be a little bit easier to start out with. And I'm going to follow my directions. It says, if given a graph, identify 2 lattice points on the line using the y-intercept if possible. So here's my y-intercept that I'm going to use. And a lattice point, again, means that my graph is crossing at a good lattice point. So a lattice point would be like this intersection of those grid marks. And so that's what we're looking for. So where else do you guys see where our graph looks like it crosses a good lattice point? I see one way down here. It looks like 3, -4 down here. So I'm going to draw a triangle in there. So I'm going to go up 1, 2, 3, 4, 5, over 1, 2, 3. So that's 5 and 3. And then you're asking yourself, is it positive or negative? And one more thing I'm going to do. Sometimes when I'm looking at these, my eye gets a little off and I pick one that's not really a good lattice point. So I'm just going to double check it. Would this also be true if I went up 5/3 again? So if I go up 1, 2, 3, 4, 5 over 1, 2, 3, does it look like it's going to hit there? Yes. So I would say that's a good slope. So I'm gonna come over here and do solid line. So my slope, again, it's going down and to the right, so that's a negative. So it's gonna be negative 5/3, and my y-intercept is going to be at 0, 1. So then I've got all my pieces. This is my b, right? So now plugging it into y equals mx plus b, we're going to have y equals negative 5/3 x plus 1. And that's our answer for that one. And you can always double check, like find an ordered pair, like this ordered pair right here. You could check 3, -4 into this equation and say, well, is that going to work? Like if I said, okay, let me make sure that this equation is correct for that line, you could pick any ordered pair on that graph and plug it in and see if it ends up being a true statement. So, excuse me, let's say we check it. So let's say we check it. This would be our x, this would be our y. It's going to be -4 equals negative 5/3 times 3 plus 1. And it's a question mark. We're checking to see if this is right. So this would be like 3/1. So those can cross off. And we're going to have -4 equals -5 plus 1. And that's going to give me -4 equals -4. Check. That's correct. So that tells me that my equation is correct, which is great. All right, let's check the dashed line. So the dashed line, we already said it does not cross at a good lattice point for the y-intercept. So let's find 2 other points. To me, it looks like there's a pretty good one right here at -1, -3. And it looks like maybe there's another good one at 1, -2. So again, that's going up 1, right 2. Let me see if there's another good one at up 1, right 2. Yes. Down 1, left 2. Yes. So that slope looks good. So for this one, this is our dashed. So my slope of, again, up 1, right 2, that's a positive 1/2. And now I need to pick an ordered pair. I can pick any ordered pair I want. I'm going to do, this one looks pretty easy. I'm just going to do this one that's at 1, -2. And again, you can pick any one. If you wanted to pick like -3, -4, pick this one, or -1, -2, go for it. Pick any of those. You could come over here and pick your x-intercept. Looks like your x-intercept's going to hit at 5, 0. Pick that one. That would be super easy. All right, but I've already told you I'm going to do this one, so I'm going to do that one. So then I'm going to pick my ordered pair of 1, -2. And I'm going to plug it into y equals mx plus b to solve for b. So my y is -2. My m is 1/2. My x is 1, because again, this is x, y, and m. And then I'm solving for b. So 1/2 times 1 is 1/2. I'm going to subtract the 1/2. And if I take away 2 and I take away another half, that's -2 1/2. So -2 1/2 equals b. And that's my b. And then you should go back and look and say, does -2 1/2, does that seem to make sense right here on my graph? Yeah, that's actually where we predicted, but we weren't sure it was going to be there. So that means my equation is going to be y equals, my slope is a positive 1/2. So 1/2 x minus 2 1/2. And that's my equation for that. All right, let's turn the page because we've got some examples on our next page. And this is one of those pages, again, typically if we were doing this in class, I would have you guys work on this in pairs at this point, and then we would go through and have different groups of students put the questions on the board, and we would just kind of walk through the problems. So I would encourage you to pause the video. So I would pause the video and see if you can do these on your own. Each of these scenarios, 1 through 8, is going to be one of these scenarios up here. whether it's scenario 1, 2, 3, or 4, like whether they gave you the information or whether you've got to find the slope or you've got to find the y-intercept, or maybe it's on a graph. So it's going to be one of those points, and then you can just go back up to your notes and look at the steps and figure it out, because it's going to be so much better for your brain to actually do the mathematical kind of crunch on your own versus me doing the crunching for you. All right, so let's look at our problems here. So a slope of -2, and it goes through the point 0.08. So this right here is my y-intercept because it's 0. Because the x is 0, that is my y-intercept. So this is going to be my m, and the 8 is my b. And so then I'm just writing it out. Y equals, and again, we're doing y equals mx plus b. So the m is -2x, the b is 8. And that's my answer. That was it for that one. I'm going to bump over to number 5. So I'm going to go from left to right on each of these rows. Here I notice, here again is a special point. I'm hoping you saw that. That is again your y-intercept. And so when I think about y equals mx plus b, okay, the two pieces I have to find are my slope and my y-intercept. Well, they gave me the y-intercept, so now I've got to figure out the slope. So m equals our change in my y over change in my x. So I'm going to do 6 minus 2 all over 7 minus 0. So it's going to give me 4/7. So then I'm going to get y equals 4/7 x, and then my y-intercept is +2. And that's your answer for that one. All right, my next one says slope of 2/3, and it goes through the point 9.4. That is not a y-intercept because we have a 9 instead of a 0 there. So that means this is an x, this is a y, this is an m. What piece am I missing? For y equals mx plus b, I'm always supposed to find the slope or the y-intercept and plug it back in. I'm missing the b, so we've got to figure that out. So again, that one should be scenario 2 from the previous page, where we are needing to figure out our b because they gave us the slope. So I'm going to say 4 equals 2/3 times 9/1 plus b. And then that's going to be 18/3, or you can simplify here. And we're going to get 4 equals 6 plus b. Subtract the 6 from both sides. And we're going to get -2 equals b. So then my final answer is going to be y equals 2/3 x minus 2 for that one. All right, let's look to the right. We'll look at the next one. This time we're given 2 ordered pairs. We want to see, are any of them a special point? No, neither of them are an x or y-intercept, or really the one we'd be looking for is our y-intercept, and it's not. So this time, this is like our scenario number 3. We first got to find the slope, then we have to find b, then we're going to plug it back in. So first, finding the slope. If I'm doing change in y over change in x, I'm going to do 2 minus 6 all over -1 minus 7. That's going to give me -4 over a -8, which is going to give me a +1/2. And now it doesn't matter, you can plug in whichever one you want. I'm just going to take the first one. And so I'm going to do, here again, we're finding our y-intercept. So I'm going to do 2 equals my slope of 1/2 times my x of -1 plus b. So I've got 2 equals -1/2 plus b. Now I want to add the 1/2 to both sides. And I'm going to get 2 and 1/2 equals b. So then my final answer is going to be y equals our +1/2 x plus 2 and 1/2. All right. Number 3. Number 3 looks like the same exact scenario where we've got the 2 ordered pairs. Neither point is a y-intercept. So let's first find our slope and then the y-intercept. So I'm doing change in y over change in x. So I'm going to do 5 minus 3 all over 4 minus 8. And then I get 5 minus 3 is 2. 4 minus 8 is negative 4. So it's going to be negative 1/2. And again, it really does not matter which one you choose. So I'm going to do find the y-intercept. So I'm plugging it in for y. Again, y equals mx plus b. So my y at this time is going to be 5 equals my m is negative 1/2. My x is 4 plus b. So then we've got 5 equals, what's half of 4? It's 2 and it's negative. So it's going to be negative 2 plus b. Add the 2 over and 7 equals b. Then we're ready to write it all up and we say y equals negative 1/2 x plus 7. And it looks like that. All right, let's try number 7. Number 7, it goes through the points 11, 5, and 11, negative 3. So the first thing I noticed is that I have an 11 on both of them in my x value. And I'm hoping you guys can go back and think through, okay, what type of line had the x's that were the same? And if you don't remember, one thing you could do is just draw a little postage stamp graph and say, okay, 11, 5, 11 we're just going to say is like way over here. 11, 5, and then 11, negative 3. We'll just put that here. And so if I connected a line between 11, 5 and 11, negative 3, that's a vertical line. So a vertical line, again, what's its slope? The slope of a vertical line is undefined. And you might need to go back and say, okay, what did Liz tell me? How do I write the equation of a vertical line? It's going to be x equals some constant, right? Then you look and you say, okay, which constant is it that's repeating? Or 100% of the time, what are the x values at? And the x values 100% of the time are going to be at this x equals 11. No matter where I put my pencil, anywhere on the graph of that line, my x's for the ordered pair is going to be 11. So that's my equation, x equals 11 for that. Another way that I've seen students start this is that they go ahead and find the slope. So they would do slope equals change in y over change in x. And they would say 5 minus negative 3 all over 11 minus 11. And then you're getting 8 over 0. And then you walk through that whole process that we just talked through, because 8 over 0, I don't know if I just said 8 over 11. If I said 8 over 11, I meant 8 over 0, and that is undefined. Anyway, you would get to this point and say, okay, an undefined slope, which special line is that? That's a vertical line where our guy is yelling like undefined words, right? Because he's following the vertical line. And then you go through this process of, oh, it's x equals some constant, which one of my values is repeating, and in what position is it in? Is it in the x or the y? It's in the x position. So it's going to be x equals 11 for that. So that's another way to go about it. Okay, let's check number 4. Number 4, it says it goes through the point 0, negative 4. That looks like a y-intercept to me. It starts with a 0, and it has a slope of 11. Awesome. This one gives it to us. Y equals my slope of 11, and then my y-intercept of negative 4. Perfect. All right, let's look at the next one. It says it goes through the points negative 8, 15, and 4, 15. Again, we've got a repeater at 15 and 15. What position is it in? Is it in the X or the Y position? It's in the Y position. It's constantly repeating the 15 and 15. That means our equation should be Y equals 15. Let me talk to you more about the Y. If we drew a postage stamp graph again. So here, this would be like negative 8, 15. So we're just going to call this negative 8. And we're just going to call this, I know it's not at all even to scale, but that's okay. We're going to call this negative 8, 15. And we're going to call this 4, 15. And so if we drew a line through those 2 points, it would be a horizontal line. So then you can go back and say, okay, in my notes, which one started, like what was the equation for a horizontal line? And it's y equals some constant. Well, how do we figure out that constant? Well, you can look back at your ordered pairs and say what number is it that's repeating? Because that's the constant. It's the number that stays the same. That's a constant there. So it's going to be y equals 15. Or you can look at your graph and say, no matter where I put my pencil, what's like even here at the y-intercept, what would my y-intercept be? 0, 15. What would this point over here be? I don't know, some negative x value, but the y would be 15. So 100% of the time, the y values are 15, which is why it's y equals 15. All right, let's check this page, because this one we're taking it from graphs. We're going to write the slope-intercept form of the equation of each line. Again, we're looking for 2 ordered pairs on the graph of our line that cross at lattice points. And if one of them hits the y-intercept, that's totally what we want to choose. So this one looks like it is, which is helpful. And then let's find another good lattice point. To me, it looks like 1, 3 is a good one. And that's going up 3, right 1. And I'm going to try it again. Up 3, right 1. That looks pretty good. Up 3, right 1. Good. Down 3, left 1. So that looks like a good slope. So I'm going to write it off to the side. By the way, that's how you show your work too, is it being able to draw those triangles on your page, and you can label the triangle 3 and 1. So it's going up 3 and right 1, which is positive. It's a positive 3 slope. What's our y-intercept? Or you can even write y-intercept as an ordered pair is going to be 0, 0. So then what we're plugging in is this value. So it's going to be y equals 3x plus b, which is 0. Do I need to put the plus 0 on there? No, you can just write it as y equals 3x if you'd like. All right, let's try number 11. So 2 good lattice points. It looks like the y-intercept's another good one. Looks like we've got a good crossing point here. So up 2, left 1, 2, 3. Let's try another one. Up 2, left 1, 2, 3. That looks like it's good. So my slope on this one is going to be negative 2/3. Again, it's your rise over your run. And then my y-intercept as an ordered pair is going to be 0, negative 4. So then you're going to write y equals negative 2/3 x minus 4. Okay, let's look at 10. 10 is another one where it doesn't look like it crosses at a good lattice point. It looks close to 1.5, but we can't just automatically assume that. So we're gonna find 2 good crossing points. I see a good one at 2, 0. And another one, where's another good one? Maybe here at negative 2, 3. So it's going up 1, 2, 3, left 1, 2, 3, 4. Let's try another one. Up 1, 2, 3, left 1, 2, 3, 4. That looks like a good one. So that means my slope is at a negative 3/4. And then you can choose any ordered pair. I kind of like my x-intercept. That'd be pretty easy. So I'm going to choose that one. My ordered pair there would be 2, 0. And I'm going to plug it in to my y equals mx plus b. And so I'm going to have my y for this one is going to be 0, because this is my x and my y and my m. So I'm going to do 0 equals negative 3/4 times 2/1 plus b. So we can either say, well, that's negative 6/4, and then you can reduce it. I'm going to reduce it now. And so that gives me 0 equals negative 3/2 plus b. I'm going to add the 3/2 over. And 3/2 equals b. which is the same as 1 and 1/2 equals b. So I'm going to look up and make sure that 1 and 1/2 makes sense. That looks like it makes sense. So my equation is going to be y equals negative 3/4 x plus 1 and 1/2. And that is my final answer. Okay, let's look at the last one. It is a horizontal line. And so you can just say, okay, well, a horizontal line starts with my slope is going to be 0. My y-intercept is going to be at 0, 4. And you know, I've had some students say, okay, well, I'm just going to plug it in. Y equals 0x, because my m would come in here, plus 4. 0 times x is 0. So y equals 0 plus 4. And 0 plus 4 is 4. You can also say, well, I know that a horizontal line is going to be y equals some constant. And then you look up and say, well, 100% of the time, what are all of my y values? Like here, this would be negative 3, 4. This is 0, 4. This is 2, 4. This is 6, 4. So then you can say, okay, well, my y's are obviously the constant one, and it's going to be y equals 4 on that. Okay, that is it for this video. Thanks for tuning in.